We are going to discussion of symmetry elements. Important individual questions will come in examination point of view. Center of symmetry, it is denoted by the C subscript ICI. So a center of symmetry is a point from which of lines are drawn by a connecting a similar group which divides the molecule into two equal halves. So a center of symmetry is a point of from which all lines are drawn by the connecting the similar group which are divide the molecule into two equal halves. A chiral molecule has a no center of symmetry. So center of symmetry nothing but what is the molecule can be converted into the molecule into two equal halves. That point you have to remember here. So a given molecule here, one molecule CH3, CH3 and HH. So the connecting the same groups imaginary lines coincide the one of the point, that point considered as a center of symmetry. Next one, axis of symmetry, it is denoted by the Cn. If a rotation through an axis by the 360 by n result in the original molecule, then the molecule said to be possess axis of symmetry. So important, if the rotation through an axis by a 360 by n result in a original molecule, then the molecule said to be possess the axis of symmetry. So we have to observe here Cn is there. Cn here n value taken 1 360. 360 by 1 equal to 360, that molecule C1 means 360 rotation is possible. Cn value n value equal to 2, we can remember the C2 molecule. When the C2 molecule how many 180 degrees rotation, you will get the previous first structure will get C3 molecule here. C3 means 360 by 3 120 degrees. The molecule given molecule 3 times we can rotating, we will get the first structure well after 3 times. For example, we have to given the trans 1,2 dichloroethylene given here. So trans here 1,2 here C double bond C H and Cl trans. So which one? Trans 1,2 dichloroethylene molecule. You have to rotate the 180 degrees in the center, that is the center of the molecule. 180 degrees taking place, you have to get the same formula, same, that is the C2 is present. A chiral molecule has no axis of symmetry, that point you have to remember. So next one you have to remember the plane of symmetry here. So plane of symmetry here, it is denoted by the sigma, an imaginary plane which objects the molecule into two identical halves is known as plane of symmetry. An imaginary plane which bisects the molecule into two identical halves is known as plane of symmetry. A chiral molecule has no plane of symmetry. For example, is at 1, 2, 3 dihydroxy butyric acid. So that is the plane of symmetry out today here. So the molecule COOH in between the here, just you have to observe here. COH here, COH, OH here, right side OH. This is the plane of symmetry. Plane of symmetry to of the identical halves. Here same side, here same. OH, COH, OH, COH. This is the remember.